Um, we're continuing on section 5.7, the substitution method. And this time around, we would like to discuss a few integrals, a few substitution method integrals that are kind of, they use a common differentiation chain rule between them. So one type is that that you see a natural log of x. In calculus 2, you learn another method to deal with natural log of x, and not every time basically the substitution would work when you're integrating natural log of x, or absolute natural log of absolute value of x. Here, if you see basically x in the denominator, though, that is your sign to with natural log of x. It's your sign that you may be able to use chain rule. And so this one is the integrand in here is basically 1 over x natural log of absolute value of x. And so in here I see 1 over x is actually appearing, right? This is equal to 1 over x natural log of x to power -1. Again, this is very common to be used, and I know that if I use natural log of x, that's the part that is complicated, right? So if I use natural log of x as u, then du is going to be 1 over x dx. And so that's also appeared in there. So basically this is going to end up to be u to power -1 du. And that is natural log of u plus c, absolute value of u. And that's natural log of, what was u? Natural log of x plus c. And again, this is a common u substitution that you see, and you have to make sure that the derivative of natural log is present to use the u substitution with that. Another example of u substitution is the integral of tangent of x dx. And so the common type that you get is a variation of sine and cosine, and then basically the other function is also present in there, so present into power 1. And so what is tangent? Tangent is sine of x divided by cosine of x dx. And so in here, if I rewrite this, sine of x, cosine of x to power -1 dx. And it looks like the complicated one is cosine of x to power -1, but the derivative of inside is present right there. And so basically you write u equal to cosine of x, and then du is going to be negative sine of x dx. And in here I see in negative sine of x dx, I see here and here together. Let me rewrite it like that. Cosine of x to power -1 sine of x dx. This part is just negative du. So it's u to power -1 times negative du. And so it's natural log of negative natural log of absolute value of u plus c. And that's negative natural log of cosine of x plus c. Speaking of the common type of integral with sine and cosine in it. I click here question 6. So it's asking you to evaluate the indefinite integral cosine to power 4 of theta sine theta d theta. Again, here I see this one is the more complicated one. That one is the one that looks like the derivative of the inside. So give yourself a few minutes. So how do we solve this? Again, I'm going to choose u to be, if this is cosine to power 4, I put in inside function to be cosine theta. Then du again is going to be negative sine theta, d theta. And here, negative du is sine theta, d theta. Here is going to become u to power 4, negative comes out, du. And that is negative u to power 5 divided by 5 plus c. And so in here, if I replace it back, I get negative cosine to power 5 theta divided by 5 plus c. And that is the answer right there.